So, ladies and gentlemen, welcome to this program in the Juris Digital Scholars Speaker Series. My name is Bernard Hibbets. I'm a professor of law at the University of Pittsburgh School of Law, and I am the editor and publisher of Jurist, which is really a student-powered online legal news service, which is actually celebrating its 25th anniversary next year. Tonight we have the pleasure of hosting the fourth, as I may have said, in our Juris Digital Scholars Speaker Series. The Juris Digital Scholars are a group of young and coming experts in the field of law, technology, and public policy. The Juris Digital Scholars Program is really an incubator program where we're trying to help and literally bring up individuals who see themselves developing into careers in this particular area. It's the first time that Jurist has done this. We're very excited by the scholars that we've had with us this summer. They've come from a range of institutions, most prominently Harvard and Yale, some from the college, some from Harvard Law School itself. But the initial crop has been great, and we are sure they're all going to go on and do great things. It was the scholars' idea, really, to start this particular series, and I want to give a special shout out to a couple of them, Connor Howland in particular, who has helped in putting this whole thing together, and also the managing director of this particular program, Zhaoli Jin, who's going to be going to Harvard Law School down the line by about a year or so, who obviously helped to put together the entire program, actually, with the assistance of Megan McKee, who's the executive director of Jurist in my office, basically here in Pittsburgh. So we are looking forward to a good program tonight. Now, I am seeing on my screen that our principal speaker, Jennifer Shin, is still connecting to audio. So I'm not sure whether we will be able to hear her or not. I'm hoping, oh, now she's connected. So I hope that's a good thing. Jennifer, can you hear me?
Yes, I can hear you.
Oh, wonderful. It's great to have you with us. And thank you very much. Did you just get connected to audio now?
Yes, just now.
Okay, wonderful. So I've already gone through the introduction here of the session. Let me say something about format, and then I'll introduce Jennifer, and we can move to her part of the program. So those of you who have joined us on previous sessions in the Juris Digital Scholars Speaker Series will recall that those sessions were moderated by Juris Digital Scholars, and they were basically Q&A sessions with the invited speakers. Tonight, our guest will be giving a talk for about 30 minutes, and then what we want to do at that point is shift to another 30 minutes or so of Q&A. So at this stage, now that Jennifer has connected to audio, let me introduce her. Our speaker tonight is Jennifer Shin. Jennifer is an expert in artificial intelligence, machine learning, and data science. She has multiple identities, and I will try to go through at least 3 of them here. She teaches at NYU Stern's School of Business. She's a product manager at NBC Universal, and she's the founder and chief data scientist at 8path Solutions. Now, tonight, Jennifer is going to be talking to us on the intriguing topic of when the truth is a lie. It's really a discussion about big data and misrepresentation. So at this point, I want to stop talking so I can leave the floor to Jennifer, and she can lead you down this particular path and educate us all in this very, very intriguing area. So Jennifer, the floor is now yours.
Oh, great. Thank you very much. So hi, everyone. I'm glad to be here, and I'm always happy to talk to anyone who's interested in listening about data science. I started out in the field before the term data science was popular. So my company, which is registered with the state of New York, I think we were the first ones to actually have a code created specifically for characterizing the company as being a data science company. So this is back in 2011. Obviously, since then, it's gotten much more popular, and a lot of people have entered the field, as well as, I think, just in terms of opportunities, right? There's been a lot of interest in industry, and good and bad, right? So I think from my perspective, someone who both practices as well as teaches, there's a lot of, I think, there's a lot of misconceptions about like what the field is and what we should be doing, as well as what's so difficult about the work, right? I think that's something that often is not being addressed when people talk about data science and why it's hard. And we hear a lot about big data and, yes, technology is difficult, but that's really not the heart of, I think, where the difficulty lies, right? Okay, so let me share my screen.
Jennifer, you might want to do that again because I think I had to just flick a switch over here. So
Okay, yeah, so I can
try it one more time.
Okay, will do.
There we go.
Oh, great, perfect.
Thank you.
Yep. Okay, so can everyone see my screen? Great. Okay, so let's see if I can do let's see. Okay, great. Get a little bit easier. Okay, so when the truth is a lie, right? And I think this is I think where we are in the field, in that a lot of people are familiar with data, have worked with data, but there really isn't, I think, the same level of maybe technical skills that we really do need to be able to work with big data and understand what is misleading about data and when we need to be careful and cautious about applying data in the right ways. And a lot of that really goes back to things like statistics, right? Math, and really being able to understand where is the technical aspect of the work, and then of course the theoretical and analytical aspects of the work as well. Okay, and so for those of you for joining, you've probably seen the description of the talk, right? So again, really misleading, misdirecting, right? Using data in a way that, I think a lot of people take it at face value. And so we see a lot of news stories, big headlines about data. And I think that's maybe part of the problem, is that headlines are often not aligned with the content. And also the content itself often is not representative of what the data or the study might be saying, right? It might be maybe a minor part of it, or something that is inferred from it, but kind of a jump from what it actually said in the data, right? So maybe a conclusion that gets drawn from it, okay? Right, so I think the first thing I do want to just bring up is, for anyone who hasn't heard of what a heuristic is, one of the first, I think, things I always think of, because I took like just about every course when I was an undergrad. So I started out as an international relations major. I, then switched over, went to Columbia, realized I couldn't pay the bill, and switched to economics because that was the hot thing to do before the economy crashed. And then did econ math and then creative writing as well, and got my graduate degree in statistics. And one of the things I took when I was an undergrad was basically psychology courses that deal with things like thinking and decision making. How do we actually test and quantify how people make decisions, and come up with things like surveys, right? How do we actually assess what someone's thinking, and then whether their behaviors line up? And heuristics is interesting because heuristics is essentially how our minds view the world, right? So we will often, as a way of being able to interpret the things around us, come up with a model, right, just sort of naturally, to fit a schema for what we understand is happening around us, right? So for instance, if you were to see, say, a clown, right, without any environment, you could be taken one of many ways, right? We see clowns in lots of things, and we see it in like a scary movie. You could see it at a birthday party, right? Depending on which context it is, right? It might say, you might think other things. Like if you saw a clown and it's like he's in a dark room, you might automatically assume it's like a horror film, but maybe it's just the basement of a kid's birthday party, right? So there's a certain amount where we actually will fill in those gaps and kind of come up with these models in our minds, right, based on our personal experiences. And I think that's really important to keep in mind, because for one thing, that's something that we just kind of naturally do, right? And it's actually something that's very helpful generally. However, when you work with data and you're working in science, this is what works against us, right? When we do that, of course, what we do is essentially we put our own biases into the data, and we will then try to look for things that maybe aren't there, or want to be right about maybe a pattern that we saw that we might recognize just from having seen it prior. That does not necessarily mean that's a good lead to follow, right? And so my second point is, right, So one of the things to think about is when we are basing expectations on our beliefs, right? So this is really, I think, where you might see a lot of news articles and people will, people will make a conclusion where, they believe something, and then therefore, based on that, right, they will then make an argument on it. For instance, right, this idea that algorithms are fair. I can tell you in the last 10 years of working, I've never had a case where I'm supposed to make an algorithm that's fair. Never happened. In fact, I would say the opposite is supposed to happen. As a statistician, I'm not looking for a fair algorithm. I'm looking for a signal. I'm looking for a differential. I'm looking for something different. I don't want a data set that's normal and normalizes, because what am I going to find in there, right? The goal is actually to figure out whether, for instance, if it's a medical study, that there isn't a differential, right? Sometimes we're not looking for differential. Sometimes we are looking for differential. But when you start looking at the idea of algorithms are supposed to be fair, and then base all of your arguments on that one idea that it should be fair, there's a huge gap between how it's actually used in industry, how it's actually used in academia, and what someone's asking for, right? So, and those people tend to be more vocal, say, in the press, right, in media. And that is always concerning to me, because, it's very difficult to get people to understand science already. Then you have people who are saying that we're supposed to make everything fair and equal, and that is an impossibility, because there's no way that the data is going to do that. And I'll talk about this a little bit more as we move forward. This is actually an impossible thing for us to be able to show with a algorithm or with a model. All right, so for instance, if you think about this idea of like AI recruiting tools aimed to reduce bias in the hiring process. So there's a lot of press now, right, about how AI is being implemented, okay? And of course, there's all these promises being made, right? Will the hiring be fair? How well does it work, okay? One of the things we should really think about when we think about these questions is equivalencies versus, when things are equal, okay? So of course, when you do statistics and you look at data, the goal is to be able to abstract out into a numerical or quantifiable model that you can use to make a decision, right? So you're taking away the, making a decision on little details and trying to find an objective model for it. Now, equivalencies and things that are equal are not a big deal when you're dealing with, maybe smaller things, but can be a very big deal when you're dealing with something as complex as data. For instance, if you're imputing data, for those of you who don't know what that is, that means sometimes researchers will have blank cells, right? Say someone didn't respond to a survey question, and there'll be blanks. And what they'll do is they'll impute that, they'll impute a value in there. Sometimes it'll be an average, sometimes it's median. There's different ways to do that. And the reason they do that is that way the data set looks complete, right? And then you have all the data filled. Now, the other side of that, of course, is you could theoretically do that. But if you were to save those results in your data set, you do also have to keep in mind that that was imputed data, because if you were to give that data set to someone else, right, they might look at it and go like, oh, everyone had 3 bicycles. That's so strange. I guess everyone owns 3 bicycles. Maybe 3 bicycles was the average, and that's actually what was filled out for every cell, right? But now as a process, right, there's a problem if you think that equivalency, right, we're at a higher level when we average everything, it's going to be the same, so we might fill it in with the average. When you start looking at the data and going back to it, now it could be a problem, because actually an equivalency is not the same thing as saying that person actually has 3 bicycles, right? Okay. The other, I think the big misconception that people have is that sample size fixes everything, right? It's like, you just need more sample size, you just need more data. Now, I think the problem with this is that's actually not that true. When you really think about the idea of, central limit theorem, right? When you really think about the idea of n going infinity, really what we're trying to do when we sample and not take a census is we're trying to find a number where the data merges, right? The sample is big enough that it merges close enough to the actual value that perhaps adding additional resources to get more data is not worth it, right? So in my view, as someone who actually practices, I'm always trying to find that number where it's like enough that, if I were to keep giving surveys out, I'm just wasting money, right? So there's a real value add there. If I know that the data is going to converge, it's going to be close enough to population. But there's another side to this. In some situations, we don't want to have that. We don't have that much data, and we don't want to wait for that much data. For instance, say you're dealing with things that are in the space of healthcare, or say, if you're looking at the criminal justice system, right? Say there's crimes. To wait until you have a sample size of 30 or 50, it seems pretty unreasonable to wait that long to see if the pattern emerges, right? You have to wait for 30 people to complain. You have to wait for 50 people to complain before you say it's significant enough, right? That's not a reasonable thing to do, because you're going to potentially be, they'll be right. And if you're, if they're right and you're wrong, now you've basically made a bunch of people endure a horrible experience of not just having endured the crime, but then also having to deal with the fact that A, no one believed them, and then B, you just have to wait because we want to rely on a model instead of, say, using our intuition, using our knowledge, using our experience. So, there is this other side of it where you do have to think about people, and you have to think about circumstance and context and scenario, because there really is damage and harm that we can do by waiting around and just waiting for data. It's not always the appropriate way to go. And then also from the other side of it, if you're looking at things that are, if you're looking at having a large data set, like you have lots of data, it might be so marginal that perhaps it's not really worth, getting more data. It might be more worthwhile to maybe add an additional variable, right? Sample size these days is not necessarily going to get the most for your, the most for your buck. You might actually be better off like integrating with other data sets. So you do have to be a little bit more, I think, you have to be more agile in terms of how you think about data and what you spend your money on, right? And also, let's see, okay. So I have an example. So I think the thing about this that is so interesting is the other side of that, of course, is everyone assumes that all data sets are standard normal, right? They were always looking for a bell curve. And that's another, I think that's another misconception that I've come across where in my work, I actually came across examples where that was not the case. And so if you're trying to get everything to a standard normal, if say you're waiting for data so it gets to a normal, well, it may never get there, right? If that's what you're, say, basing it on, that could be problematic. So I actually had a project where I basically had to figure out, we had TV data and we had digital data. So people who own televisions, people who had a computer, right, and were part of a panel. So I had to figure out, is there a way that I can merge these two groups together? And one of the big problems with this, of course, is there are people with TVs who have internet. There are people with internet who have TVs. So you have to actually figure out, like, okay, I have to remove everyone in the intersection. And of course, the other side of this is, and then you got to think population. It's not enough to just remove the intersection. You got to think, well, do I have data on people who don't have either? Because that's also something that has to be taken into consideration. You can't just scale it out as, the entire population is assume that everyone has a TV and an internet, because that's actually not true. Yeah. And so actually one of the interesting things I think that I came across with that data set was the fact that, in fact, I had to merge a couple of surveys to be able to find this information. And in doing so, I noticed that there was a skew in the data. So there was a skew in terms of the split between men and women and who had internet and who didn't. And one of the surveys was, I think, about 50-50, and the other one was 80-20. And so, you just kind of think about, like, okay, well, how do we get the data? What's the reason? Is this a problem with the quality of the work? And it turns out that one survey was administered online and the other survey was not, right? So again, these are methodology things that, I think a lot of people ignore when they look at big data, right? Because you just get the data, you don't think about where did it come from? How is it gathered? It can actually make a huge difference in terms of your model, in terms of the accuracy of the data, and what you can actually do with it. The other part, of course, is that when you're targeting, say you're using this data in the real world, random sampling is not always what is used in companies, right? When you're targeting certain demographics, if you're doing stratified sampling, it's not always going to be normal. And so I think that's another thing to keep in mind, that when you read an article, when you're doing research yourself, keep in mind that there is more than one type of sampling that happens. It is dependent on what you're working on. And it's not always the case that you want random sampling, right? For instance, if you're targeting a specific group of people, right, you want that group. Your population is not the US population. Your population is that group of people you want to target. So you have to keep that in mind and not realize, like, again, always going to this national population, which is said to be a default for many people, is problematic because, in fact, if you're trying to go for, say, people who make a lot of money, right, who have certain jobs and certain degrees, right, they're a small percentage relatively. And so you can actually introduce bias into your data by trying to skew it to something that actually is not the appropriate model. Okay, so really when we think about, what are we doing when we look at algorithms, when we look at models, when we look at data, right, really, what we're trying to do is to find models where we can use information, right, that can be used to find information that's representative, right, in the case of populations, or generalizable, right? So essentially being able to use what you find to other problems, right, other data sets. And of course, what do you do when we do that? From a technical perspective, what that means is we remove specific details from the data, right? And that's common practice. But of course, there's another side to this. You have to also include that in your analysis, right? Statistical analysis, or some of my students, you have two parts. It's not just calculated statistic. The analysis part is the part where you explain what the results actually say. And so that's really important, because that's where you talk about things like, where are the implications? What are the limitations, right? Why did you choose this method? And then, of course, where it's not appropriate to be used. And I think skipping over that is, you know, for me, as if I'm reading someone else's research, right, I lose out on being able to benefit from their research by not reading it. And then on your end, also, you also don't get as much credit, I think, out there by not including the, you know, the full robust analysis of what you did and how you did it. And really, that's really where the value is when you think about things like models and the benefit of them. And I always tell my students it's a requirement, right? It's not, I personally don't think it's an option. I think you should be including that information, because really, if you didn't include it, I mean, from my standpoint, I assume that you either didn't know what you're doing or you're purposely obscuring your results, right? Like, because I don't really know why anyone wouldn't analyze data and say, okay, there's certain limitations, because again, standard practice in science. So another topic that really comes up these days, right? Biased algorithms are easier to fix than biased people. So, you know, that's true, sure. That is, unless biased people are the reason why the algorithm is biased, right? So if you think about NDAs, right, non-disclosure agreements for the last like 20 years, if you worked in finance, if you work in any industry these days, a lot of people have NDAs, right? You can't talk about your job, you can't talk about things that happen. And then, of course, with a lot of the Me Too movements that are coming out, right, there's been a lot of talk now about, oh, NDAs are problematic. Now, from a stats standpoint, you know, it's not just that it's problematic. I think from when you really think about data, the really crazy thing about that is we have no way of knowing how many cases that is, like zero knowledge, right? We have no way of knowing what percentage of the population actually, you know, might have reported something. We don't know if it occurred. We don't know if how many times it occurred. We don't know, you know, we have no information on it. So there's not even a way for us to actually be able to estimate out in a model, right, what the error would be, because there is no information available. So at the end of the day, really, when you think about it, the biggest hurdle that we actually have with, you know, getting good data is if the law prevents us from being able to access data, there's nothing to do about that, right? So there is this other component where the law is extremely important in not only protecting, you know, things like our privacy and our rights, but also in terms of data, making sure that, you know, data scientists, statisticians can get data that can be used, right, in a good way to help the public, right? And really, you know, even I've had this happen to me in industry. I've had access to data that I cannot report on, because technically, right, the legal, you know, restriction says, even though I found something interesting, I'm not allowed to report it. And so that's the real thing. I've seen it in more than one industry, right? I've seen it in pharmaceuticals, I've seen it in media. And so that's something that does happen quite often. And I think, you know, again, we should really keep that in mind, that just because, you know, we don't have information does not mean things don't happen. And that is where the law is actually very, very important for, you know, the field of data science. So another takeaway I would say is inferences are not facts, right? When we infer information from a model, we're making a statement about the data-driven model. So meaning we can say statements related to the data we have. We cannot, however, say statements as a whole. So you might see articles where people say, oh, this one study said, you know, found this finding, therefore it must be true everywhere, right? And that's just not true, right? One study says one study. You know, if you want to generalize it to a bigger population, you do need to actually have more than one study to be able to base that on and actually assess whether or not even the two studies are comparable, right? I think that's another place where people really, again, same steps, right? You have to test it, you have to get data, you have to analyze, you have to validate. Statistics is not just as simple as just plug and chug and you're done, right? There actually is a huge process, and really, if there wasn't, I think everyone would be a statistician, right? Because everyone says you make money from it. So obviously, it's actually a lot more difficult than just, you know, throwing in some data somewhere and just getting some numbers out of it. And if nothing else, I would say, you know, having blind faith is one of the biggest things that I've seen in terms of misconceptions, right? So, and by that I mean when a algorithm or a model or, you know, some statistical analysis produces a result, I see many arguments based on that result is true. And then they make, again, similar to the first one with belief, right? People assume that if an algorithm produces a result, it's true, and then they go backwards from there. But of course, again, unless we validated the algorithm, unless we validated the result, right? And this is where things like black box algorithms are problematic. You can't assume it, right? We should be asking them to produce more evidence. We should not be going, okay, well, it's true, therefore now let's try to figure out the 8 million reasons why it's, you know, and then have everyone kind of, you know, pick it apart. You can pick it apart forever, because for every one true answer, there's an infinite amount of wrong answers, right? So it's kind of like a pointless exercise when you really think about it, because you can't sit there and refute everyone at every possible wrong answer if, in fact, what the answer actually is right, is that, well, we made an assumption that's just not accurate, right? The assumption is inaccurate. And to sit there and try to argue every point actually it works against us. And a lot of the stuff that's happening with data, I think, why is it such a big deal? Well, if you really think about COVID-19, one of the things that really concerns me personally is the idea that we had so many papers that got published. All right, 11,000. I didn't even know that there were that many working scientists out there. Okay, 11,000 papers in like 3 months. Like, wow. I mean, I always thought I was alone, but I guess not, because there's so many of us out there. And I don't have a problem with all the papers per se. I mean, a little concerning, granted. The bigger concern I have from a data science and machine learning standpoint is, at some point people went, well, this data is available. Let me mine the data. So why is that problematic? Well, people published a lot of work before they thoroughly examined the data. Right? We didn't have as much data as we do now. When you start mining the data models are based around popularity. Okay, like, meaning it's not going to find you the better answer. It's not going to find you the important answer. It's going to find you the popular answer. So you're going to get the popular answer of why everyone's wrong. Because if there was the right answer, we would have fixed it by now. And so to do this before we have again, without the validation, without having done the work for it, we're skipping steps, and that's actually very, very concerning for that reason, right? We have to be very, very cautious about when we actually can, look at the result and assume that it's true. And typically, if you think about, like, say, someone like Einstein, right? There's one Einstein, right, from his whole generation. He's an outlier, okay? His work would not have been picked up by an algorithm. So if we're going to start making all of our decisions based on how popular it is, people like Einstein, who's very well known for not being able to get a teaching job, right? Like, I mean, what's he going to do at that point, right? So I think there is an importance in understanding that when we use algorithms, it is sort of like a popularity contest. It's not a matter of who's smarter or who's better. It's really a matter of, like, what's more prevalent, right? Even things like words, what word comes up more. But if we haven't found the answer yet, all that shows is that we have a lot of wrong answers, right? And so we really do have to know the work. You can't just rely on some machine learning algorithm to give you an answer and think that's going to be sufficient. And I think that's really, we should all be concerned about that, because if you think about things like, say Boeing, last year with all the plane crashes, right? If you're on a plane, you can't fix the algorithm when you're on the plane, right? Like, you really have to be conscious of the fact that AI has now taken over everything. And the most concerning thing is the majority of people running AI projects are not technical. And that's very concerning to me, because that means they don't know the difference between a popularity, voting type of algorithm versus, say, a regression, right? And that distinction is what makes the biggest difference in terms of which result do you follow, which model is better. These nuances are actually very, very important. It's not a matter of choice, it's a matter of accuracy. Is that about 20 minutes?
Professor Hibbets, you're muted. I'm sorry to interrupt.
That's fine. No, it happens to all of us, I guess. Thank you very much, Megan. I appreciate that. I was just applauding Jennifer for her presentation, and saying that after such a provocative address, I'm sure there are multiple questions from the audience. We can take questions in a variety of ways. Megan, I think you're going to be monitoring the chat for this, but if people have live questions, we will certainly take those in preference at this particular point. So you can either wave your hand at me if you're visible on the screen, or you can raise your hand electronically if you know how to do that within Zoom, and I can take questions as I see them from those of you who have them. So let me pause and see if there are questions that are ready at this particular point. Questions?
And Alex Chen did post a question in the chat. Alex, I don't know
Thank
if
you, Megan.
Go ahead and announce your question to the audience, or we are more than happy to read it and introduce it that way too. So.
Hi, I'm here.
Hey, Alex, go for it.
That presentation, it was awesome. I was wondering, you've described a lot of like the errors that can pop up in data science. And I was wondering to what extent that's the result of just negligence on the data scientist's part, like they just forgot and they made the mistake, or is it like, are they actively trying to manipulate the data for any particular agenda? Like, to what extent do you believe it's either of those happening?
Well, I think I find it actually it's sort of a sad statement that I think it's actually neither. I think part of the reason, like what concerns me about the field is, when I was in school, this data science wasn't a field, right? And I actually did get not the best response from my professors because I studied so many different fields that basically they felt I was not a serious enough student at the time because everyone just picked one major, they stuck to a track. I felt that from having worked in industry that I wanted to be able to bridge a gap and work with things like technology and data. And so I was working with data. I've worked for over 20 years, but this was not a field like 10 years ago. And I think a lot of programs will tell you that it's been around forever, and what they've done is been around forever, right? This is in some sense a new field because there's demand for it. And I think that's what, from my perspective, is concerning because I wish like science had been slower about maybe developing the curriculum for this stuff, because I think there is a lot of work that should be done and could be done. But everyone jumped on it. So the challenging part is, how do you then, as someone who is young, figure out how to bridge the gap between what a researcher teaches you and then how do you become a practitioner? Because I don't think it's obvious, and there is this like nuance of like, for instance, like how do you tell someone bad news, right? Like I've had to learn over the years, like if you're going to give someone like somewhat bad news about like the data is not a good data set, there's an art to it, right? And you can't just tell your boss like, oh, it's terrible, right? People will get fired for that. But there's like things like you want to come up with the solution first, like come up with a couple of solutions first and then approach them, right? And I think if more data scientists knew how to do that, I think perhaps then maybe some of the errors wouldn't slide, because chances are, if you are at the lower ranks of your company, your boss told you to let it slide, probably, right? Because in my view, technical people care. Like engineers really care about the work. They're generally not the ones that say, I don't, I'm okay with them because I'm gonna send it through. It's usually their manager who says, you know what, I want to work on something else, I want you to send it through. Realistically, that's what I've seen in industry, and I think that's the predicament for people who are younger, who are working in the field, because you don't have much skin in the game, so you're kind of subject to what you're being told.
Thank you, Jennifer. Megan, I see we have another question in the chat from Connor. Can you take us through that? Or Connor, you can ask the question yourself, actually, at this point.
Yeah, sure. Well, thanks for the great chat, first off, Jennifer. I'm just wondering how the lack of like any sort of federal data governance structure in the US like impacts the type or quality of data that we get in the US, and like if you could maybe contrast that to how maybe someone in your position in the European Union works under the GDPR, and if that actually helps anything with things like algorithmic bias or other sorts of poor outcomes. I'd be interested to know your thoughts.
Yeah, so I've seen how terribly companies treat your personal information. I start all my classes with my students. I always go, I know everyone thinks that everyone young knows how to work with data, but I always start with like, have you turned off the tracking on your phone? And most of them have not. They don't know where to find it. By the way, it's there, but it's like not super easy to see, right? Because from my standpoint, in general, I'm always given these very challenging projects, right? I don't need to know every individual person's exact location and information. I care about like the pattern of behavior that is prominent, say, within a group. Like what's popular, what's the trend, what's the pattern. For that, I don't need to know like every single person, right? I just need to know, say, up to a certain level of granularity, right? But the reality is most companies, because they are not confident, say, in what they're doing, will want to collect everything so that they have it in case they use it later. Now, the reality is, of course, they don't actually use it later. What ends up happening is they kind of forget about it and they get shut, somewhere to the side. And that's when your data might be at risk to actually get hacked, right? Because they're not looking at it, they're not focusing on it. But that data is still valuable to someone who wants to, say, steal your identity, right? So I do think things like GDPR, it's not only important, but I think it's like kind of a shame that our country doesn't use that. We do have the law that passed in California, thank God, like there's something, right? But that's something where I think more people should have been, I think, aware about, because I'm sure we've all gotten probably emails and letters by now, right? That we've gotten hacked, that had our information stolen. And I can tell you, last year, someone actually went to my bank and pretended to be me. I actually got a call from the bank because they were trying to withdraw every dollar from my account. So that actually happened. A person actually went to the bank posing as me, and they don't look like me, which is what tipped them off, right? But people are getting bolder about it, right? People are taking that information and really trying to do what they can with it. So, I think if you're good at what you do as a data scientist, you don't necessarily need that level of granularity. And I would be okay with companies asking for that information if they did a better job of securing it. right? Hopefully with some of the laws that have recently happened, I would be hopeful that they will follow it. But I've also learned working in corporate America for so long, they don't actually just follow the law because it exists, right? A lot of times it's like the cost benefit analysis of like, well, it costs me more to get sued, or it costs me more to actually hire people to do it. So, again, like that's the real risk, I think. And I think, one of the things I like about, I think, the younger generation, right, is that there is a sense that you don't want to, you care about protecting yourselves. You care about, having things be fair. And I think that's a good thing to do because, I will definitely tell you from my end, like I've seen all the things that can go wrong. I was, in finance when the financial crisis happened, and in tech was some of the stuff that's been happening now. And it's not great. It's definitely not, it's not a fair system, right? And I do think that it would be great if it was a fair system. I think that's something we should really all work toward, and really try to use data in that way, right? How do we use data in a way that we can, find a way to do it? In terms of the standardization of data, the government's always been bad about that. I did some, I cleaned up about 4 million data points in 2014 about the FDA's, like, the drug side effects, and they had data available, but basically what they would do is post it and then purchase it back once it was cleaned by someone else. No joke. That's how the government actually got the data back. And then at some point they released some beta of a API and said, look, it's all clean. And I went, hey, where's the data mapping? Because I don't see a mapping. Like, how do we know that your data actually lines up? What they did was they got a startup to do it, didn't check the work, and just assumed it was clean. I checked the data. It was not actually one-to-one accurate, right? That's something else I've seen where transparency and openness are not the same thing. And that's the big thing to take away with government data. They will say we're open because we put it on GitHub. Well, see, you put it in GitHub, but you also changed the wording 4 times. Like, like a John Hopkins data set, right? That's one that they keep changing it, right? And again, like, I keep seeing, errors. They also didn't put things in there, like, the mappings for all the different headers that they have for all the different files, right? That's definitely a challenge. I don't know how you're gonna make the government do it. My approach has been to actually, come up with content that will hopefully help other researchers, like putting together, maybe making that data set available for the public. I think the best way to fight that sort of thing is, use your skills, right? Use your skills and make it available for more people.
Thank you, Jennifer. We have another question in the chat from Shang Chin. Although Shang, I see you're visible on the video here. Do you want to ask your question yourself and unmute yourself?
Sure. Yeah. Thank you.
Great, thanks.
I think Jennifer, first, great presentation. I think it's very interesting and very provoking to really understand the difference between technical folks and non-technical folks writing papers. So, and I really am interested in what your thoughts are in terms of like learning data science as like a graduate student, especially those grad students that are non-technical, really coming from most of the social sciences. And in follow on to that, then what do you think of those coding camps that are about 3 months long, and people from there are getting great jobs at some great tech companies?
Yeah, I've already heard backlash from companies who've been hiring from tech boot camps. So I'll tell you that much, right? So I've already been, it's interesting how those things work, right? Because companies generally aren't going to admit it publicly. So you'll hear about it through through your networks and your channels, right? What their opinion is. So they did invest in that. I think now at this point, they're kind of almost going backwards and trying to get people with more experience, which is kind of a strange thing because they were trying to get rid of them 5 years ago. So I think I don't know. I mean, if you are someone who's very technical, I'm not one to talk because I never finished a computer science course when I was in school. So, I just couldn't sit through it. Like it was like learning French almost, because they're making me learn all the stuff that I'm never going to use in a way that I'm never going to use it. So I just learned on the job, and granted it was harder. But I did get it to a proficiency enough that, like, for instance, I can code in R and Python and SQL and Node, and I've built technologies, I've launched technology, I have patents, done the whole thing, right? And so it will take longer. For me, I felt it was more worthwhile for me to do it by exploring what I was interested in. Like I explored it, like I wanted to learn how to do it, and I felt like taking the courses in a more formal way took away some of that like enjoyment of it, right? The challenge of it. So I think it's up to the person. Like there are some people who go to the coding, go coding camps because maybe they didn't have an opportunity, right? And I don't want to, take credit away from them. That if that was, something that helped them in their career, that's fine, so long as they realize that when you're at the job, it's not easy, because at the job you're dealing with people who have more years experience than you and also are more proficient. So at some point it evens out, right? If you want to keep that job, generally you're going to have to like start really coding a lot and really being able to do it. The other thing I will say is I think everyone needs to not necessarily know how to code, but at least know how to read like the stuff people try to sell you. Like people are trying to sell you things like, it's almost like they're trying to sell you magic beans, right? You're trying to sell, like everyone's saying like AI does everything. AI does not do everything. If AI was doing everything, then we would actually be in a much better situation right now than we are, right? So really think about like, actually the analogy I use is, okay, if you go to a car salesman or if you go to a car like mechanic, would you ever go, hey, just fix it for me? Would you ever just go to them and be like, oh, just fix it for me? No, you go, okay, I want this specific thing fixed, right? Well, to go to someone with data and go, hey, just fix it for me, you're going to get a huge bill of things you didn't need, right? Like almost guaranteed, because they can do that and make it look like they did work. It's so easy to do, right? So there's a real risk in not being technically able to speak to people about things like data, because honestly, it puts you as a target in terms of being able to, like they'll sell you things that you don't need. And I think if you want to be successful out there, that's a big risk to take on. I think it's going to be, and I see it more and more because more people learn the jargon, right? It's not actually true, but you have to know enough technical, you have to have enough at least technical experience, not necessarily coder, but at least have experience, say, looking at code, understanding how the process works, to then be able to understand like when someone's selling you something that just doesn't sound right.
Thank you, Jennifer. Cameron, I see you've got a question in the chat. Do you want to just articulate that yourself?
Sure. So, hi. I really appreciated the organization of your talk and how it laid out a number of different ways in which data can be misrepresented or used improperly. And I see these recommendations as things that could apply to both people who are producing analysis, as well as people who, like us, as members of society, will be consuming an analysis like this in the future. So I was wondering how you think about, as you decide how to spend your time to reduce this problem, how you split your efforts between helping people producing analysis versus like educating consumers so that they're not duped by things like these.
Yeah, so I don't sleep much, as you know. By the way, I like the Mandelbrot set you have there. Yeah, so, I don't sleep very much, which is unfortunate, but, that's the reality, right? Like there just aren't enough hours. I try to give as much talks and speak, when I can, as much as possible, because I think part of it is that people just, if no one's out there just kind of countering the stuff everyone else is selling, then, people over time, you get worn down by that, right? You start feeling like, oh, well, I guess everyone else believes it, so maybe I should too. And so I do try to speak as much as I can, as well as, kind of come up with content. I think at this point, one of the things I'm doing is actually looking into writing a textbook, right? Looking into actually producing more like course related material, because, I do see that there's not enough, I think, there's not enough content out there where students are learning the bridging the gap, right, between the theoretical models and the actual application, and how to actually, understand how to bridge that gap. And so, it's hard. I mean, it takes me a very long time. For the last few years, I've been, doing talks and then also papers, research, right? Because it turns out, like, a lot of researchers are also interesting because they do want to know new things, right? They want to know new algorithms. And so, like, for instance, I got invited by the government of Korea to go and speak, at a workshop there and kind of tell them what my work was, right? Because I've done population studies and worked with, FDA data and all of that. So, I wish there was a clearer map in that sense. Like, if there was one, I would definitely do it. But my experience has been like, there's a lot of doors that shut, right? There's a lot of trial and error. There's just, I think, you have to be very committed to, I think, want to, put things out there and help people. And better or for worse, I guess I'm one of the people who I really do care about, more people being able to navigate this. And in part because, my work will never get appreciated if other people don't understand, right, what I'm saying or what I'm doing. So I think it's sort of symbiotic in that way, right? Like, I am hopeful that in helping other people understand data, right, that hopefully other people will take on the work, things like make better laws, right, being able to have, better processes in place. Like, I would like to be able to use my credit card and not have it, like, give me the wrong error message, right? Like, even things like that, like having servers that work, and I think that is really, in my view, why it's so important and beneficial to actually, educate people. Because the hope is, again, like, my quality of life will be better in the long run, because I can't do everything, because other people will then be, empowered to go and take this on.
Thank you, Jennifer. Cameron, that was a great question. So we've got a couple more here, Jennifer, that were submitted previously by the digital scholars, and I'd like to roll them out if I could before we wrap up tonight. And this one sort of stems from your last answer here. It's an extension of that. What tools exist or should exist in the fight against misinformation? How could partnerships be forged across nonprofit, private, and academic institutions to develop mitigation strategies? What steps can be taken from an individual and as a collective to form this digital baseline knowledge?
Yeah, that's a good question. I've seen a lot of places try to do this partnership stuff, right? And from different areas, right? So I have, my company has partnerships with, say, IBM, Microsoft, technologies. I also teach at NYU, so, I also have that. But, a lot of the people who are in those partnerships are generally more tenured. I don't have enough skin in the game for that, for one. And so, that's a tricky one for that reason, because I think if you're younger, unless you're really in there, like it's very difficult to get in, right? Also, they do kind of require you to do a lot of work for it, right? You'd have to be like willing to, like, I don't know, do some of the paper, the work they do for their papers. I think there is enough also gap that, like, I don't necessarily know if that's necessary, honestly. I think if you do something that's actually valuable, then I think go in with that, and then academia will probably be on board. But in general, my stance on this has always been, like, whether on the academic side, the research side, or just industry side, you always want to go in with the best deal terms you can get, right? Meaning you want to go in having something that someone wants, because if you have that, then you will be given you'll be given more, opportunity, right, to be able to navigate what that partnership does. Because if you enter into it at the lower ranks, right, you're just going to do what everyone else says, right? And unfortunately, and this is true of I think of everything out there, not just with these partnerships, but also in industry. What that means is your job is now subject to whatever other people are doing, and not necessarily based on the quality of your work or, what it is that you contribute. And so, I think for that reason, in general, I would say, like, for these partnerships, it's great if everyone has something to bring, but there are also partnerships that are there just to make themselves feel good and sound great. And there's a lot of that, right? Like, I was very critical, I think, last year when Stanford came up with, and it's probably gone already, by the way, like one of these, ethics related, groups that they had. I'm like, I mean, they have the money for it, I guess, but really what happens is academians, like, they tend to change the group that they're in every 3 years or so, and it's a new name, it's a new institute. And so if you actually look at it, they just keep rebranding it right over time. So, I mean, I get to be a little skeptical because I'm like, I keep looking for the work. It's like, oh, now it's a new name, it's a new place. So, there's that, right? And there's a few that do it well, I think. I mean, you guys have been around for a while, right? So obviously there are some that have been actually doing the same work. But yeah, I think it's great as an idea, but I find that what will end up happening is industry will give industry, what they give is they give you free credits, right? What does that mean? Amazon money, IBM money. They give you servers, and then they expect the researchers to do the work, right? And then that's usually how that part of the partnership works. They usually don't, and I actually know this about some of the top people at Facebook, that they basically got a huge grant from the government, and essentially all they did was attach their name onto it, right? So they got the grant, but they were never around to actually do the work. So, again, I take it with a grain of salt, and I would actually say, in general in life, always be skeptical, right? Because just because it sounds great doesn't mean that it'll be great for you, and it doesn't mean that it's going to be great work.
I love the skepticism, Jennifer. That's a big dose of reality. Thank you very much. I do appreciate that. Let's try another one from the digital scholars. Given that there is an exponential growth in the use of data analytics and science as tools for decision making in both the private and public sector, do you have any thoughts on how we can educate the industry to strive for careful and sound data analysis and ensure misleading results do not result in material harm?
Laws, I think, are the best way. Because I'm going to tell you right now, so ethics is interesting because everyone talks about ethics, right?
Mm-hmm.
I'll explain to you how ethics actually works in the industry. At some point, right, there's a disagreement, and whoever's with the highest ranking in the discussion, right, they get to have the say because it's employment at will and they can fire you for any reason. So as someone who is below their rank, you're generally not going to be very vocal. So that person gets to make the decision. So it turns out, at the end of the day, you can definitively say, because the work environment is that way, that probably if that decision got made, it was made by one person at the top, right? And so the problem with that also is that even if your argument is correct, usually the argument comes down to one thing, which is it legal or not? And even if it's like, for instance, like I used to know people who work with Facebook data before Cambridge Analytica years and years ago. Like the books were available, you could, do all of that stuff. I chose not to do it because I came from finance, I care about compliance. I'm like, just because it's not legal yet does not mean they'll come back later. Government can come back later and charge you after the fact. I'd rather not take that on. And I've had political campaigns approach me every year, right? Some of the big ones, some of the presidential ones, asking me to look into that work. I met with them. I was not, really enthusiastic because personally, I don't care for, like, I don't need to have that type of work in my view. And also because what they actually built was just like a front end, user interface. So it's kind of almost like a double scam in a weird way, right? So I think that's the issue I see the most often, is that the conversation always boils down to, is it legal? And so when it is not illegal, by the way, not even legal, not illegal, they do whatever they want. And so when we don't have repercussions for businesses, right, or some of these executives, there's almost an incentive to break the rule. Because in the meantime, they're making a lot of money, right? And they're actually doing very well. And the irony is, the more successful they are at it, like say a place like Facebook, right? It's less likely that they're actually gonna get in trouble anyway. So there's, again, an incentive for them to actually, push that boundary and try to get away with more.
Okay, great. No, that's great. And the third and last one I'll try to sneak in here. What are some strategies data scientists are developing or regulations organizations are making to ensure representative data?
So I think what's really interesting about representative data, if you think about all these conversations about bias, right? It's really interesting to me because, you think about, like, I read an article earlier today, and it said, like, we think that you should remediate the model because it's not representative. We see bias in the hiring practice because of this algorithm. And therefore, we believe what you should do is you should introduce a variable to center, right, that variable, the race variable. Now, what's really fascinating about that argument is, essentially what you're saying is, I think you should fight bias with bias. We should add more bias to the model, because then we'll just count the bias, but that brings up the question of how much bias is the actual right amount, right? Because data changes, things change. So that's actually, it's almost like saying, like, two wrongs make a right, really. When in actuality, when you think about the model, if that model did not in fact find a differential between two groups of people, right? Say one group was not being rewarded as well or paid as well, then you basically have no basis for having any legal action to actually remediate it. So in fact, everyone's pushed to make everything equal and even. It actually obscures the fact that actual discrimination happens in this country. That in fact, there are disadvantaged people. There's definitively people who are not being given a fair shot. So, the data itself is not the problem if you think about it. It's what people did with the model, not what the model said. What the model said is important. The model says that there's a differential and that we should be more conscious of the fact that some people are not being given opportunities. That's really important for us to have this information. The choice to then take that information and then use it in some AI in some very simple way, that's a very separate thing than the actual model. And I don't think the model is the problem. I think it's what people then, people will say, oh, data is the problem, because then they don't have to take ownership of the fact that, no, you decided to use this in an algorithm. No one said that that was the right actual action to take from this, right? Probably should have thought that through. But, and I think that's the danger. Like, we have to be very careful not to say that it's the data and not to say it's just algorithm. Because, that's basically the basis of science, right? Like, it's what we do. We look at data, you come up with results, and there's always that risk that if the public starts misconstruing the work that scientists do with the actions that other people take using these results, then, things like scientific funding goes out the door, right? And as we're kind of seeing these days. So, I am very careful to differentiate the two things, but also to basically say that this is how we can educate the public, right? When you hear about what people are doing, they will often use things like data is such a big problem as a way to excuse themselves from the fact that what they did with the data is the problem, not the data itself.
You're really calling for data responsibility.
Yes, accountability would be great. But again, laws might be necessary. I think it's the other side of it because, I think and it's not like you have to go to jail, right? But I think there's, some penalty, some fine would be nice, just because I think without any sort of, because the internet is so available and free for everyone, I think everyone just goes, I'll just take my shot. And they'll just put stuff out there. They'll go on Medium and post an article. They'll post some blog. And I do this thing with my students where I basically let them do an open book test. And I let them Google their answers. And the reason I do that is because there's so much bad information out there. They all think they'll find the right answer. But they sit there basically the whole time, never finishing the exam, going, I don't know which one's the right answer. Because that is essentially the problem, right? Like, yeah, you don't know which one's the answer. That's one of the reasons why it's not as easy as just Googling something.
Thank you very much, Jennifer. That's terrific. We are now coming towards the end of the session. Are there any outstanding questions? Did anybody want to get in with something right at the last here? Okay. Well, in that case, I'm just delighted with this session. Jennifer, this has been wonderful. It's been provocative. It's been a reality check. I really want to thank you for such a wonderful presentation and for your provocative answers to all the questions that were asked. Really, you had a lot of energy and some really good ideas. And so I really think that we got a lot out of this. So on behalf of Jurist, on behalf of the Jurist Digital Scholars Program, thank you for joining us tonight. And yes, we can all applaud in various ways, muted or unmuted, or in sign language, as it were. But no, this was truly tremendous. And I want to thank again the organizers for having pulled this together. So once more, a shout out to Connor and Zhao Li and Megan and others who have made all of this possible for us, Alice as well. Thank you for doing all of this. So we will look to see everybody back in some way, shape, or form for the next session in this series, which I believe is next Thursday, the 20th. Look for an announcement about this coming from Jurist if there isn't one up already. But we will look forward to seeing you there. Thank you again, Jennifer, for this evening. And that concludes this evening's presentation. So thank you all.
Thanks so much.
Thank you, Jennifer.
Good
Bye-bye.
night. Bye.
Good night.